first kind of energy I would like to talk about in this unit is kinetic energy, which I mentioned is the energy of motion, okay? And for a second, I want you to put aside any knowledge you might have about what the formula for kinetic energy is. And I want to ask you, how might you build that equation simply by knowing that kinetic energy is the energy of motion, okay? What must it depend on? So this is a game I like to play because it almost tells you you don't even need a formula sheet when you take an exam. You can reason out many equations on your own, okay? So for example, I know that if kinetic energy is the energy of motion, it better depend on V, right? There must be a V in there, okay? And I'm further going to use my reasoning to say that it shouldn't depend on what direction the V is going, right? If I'm running in this direction at 100 meters per second, or if I'm running in this direction at 100 meters per second, right, which would be very fast actually, I better have the same kinetic energy. It shouldn't be positive or negative, right? The bottom line is I'm moving the same amount. It shouldn't depend on which direction in space I'm going, right? And when that's the case, often a variable is squared. Not always, but often. And so why would that matter? Why would that make it so that it doesn't matter what direction you're going? Well, anytime you square something, whether it's negative or positive, right, it becomes positive. It becomes an absolute value, okay? So I'm going to tell you that in this case, because velocity does not depend on the direction, your velocity is squared in this equation. What else should kinetic energy depend on? Well, you would imagine that a fly buzzing around at 100 meters per second would not have as much energy as a Scott running around at 100 meters per second, right? I would have more energy than the fly would. So that also implies that there should be a mass there, okay? Kinetic energy should depend on mass. And I am going to argue that there is nothing else that kinetic energy depends on, but I will say that there is a 1/2 constant that comes out in front, okay? And if you go to the next slide, it says the equation, right? The kinetic energy is equal to 1/2 mass times velocity squared. So we did a good job. Good job, guys. Okay? And that brings us to our first misconception question. And the question is, when the speed of your car is doubled, by what factors does kinetic energy increase? If you'd like to pause and see if you can solve this on your own first, I encourage that. If you'd like to stick with me for a second and try to solve it, we can do that too. So what happens to kinetic energy if I'm doubling velocity? Well, let's see. I'm going to find out this new kinetic energy, I'll call it Ke prime, that happens when I double my velocity, okay? And as you can see, this 2 is going to get squared and that V is going to get squared, which means I'm multiplying this whole thing by a 4. So this becomes 2 squared times everything else I have here, which is 1/2 mv squared. Okay? Okay. So that means that my Ke prime, my new kinetic energy, is going to be equal to 4 times my original kinetic energy. So by what factor does the kinetic energy increase? The answer is 4, which is option C. Okay? All right. I would like to also do one example here. Okay? And this is based on a true story. I love problems that are based on true stories, which you guys probably have noticed by now. All right? And I wish that I could have one of you guys read this while I'm erasing. It'd be so convenient. I think I might start having like a one-student audience, a socially distanced one-student audience here to answer these questions. So here we go. In 1896, true story, in Waco, Texas, William Crush parked 2 locomotives at opposite ends of a 6.4-kilometer track, fired them up, tied their throttles open, and then allowed them to crash head-on in front of 30,000 spectators. Really cool, really dumb. Hundreds of people were hurt by flying debris. Several were killed. Assuming each locomotive weighed 1.2 times 10 to the 6 newtons and its acceleration was a constant 0.26 meters squared, what is the total kinetic energy of the 2 locomotives just before their collision? Okay, I'm going to start this problem by asking what is the kinetic energy of just one of them, right? Because if I can find the kinetic energy of just one of the locomotives, so here's locomotive number 1, I don't know. I don't know what trains look like. I have not been on enough trains. Something like that, right? And they're going, right? The question is, when they meet in the middle, what is the speed of one, right? Just one of these locomotives? Because if I can find the speed of one, all I got to do is double the kinetic energy, and then I have an answer. Okay? All right. How do I find the velocity of one? Well, it starts out from v equals 0, right? And then it's accelerating, accelerating, accelerating until you have some v2, right? So the v1 is equal to 0. If we find the v2, we could put that into our kinetic energy equation and have an answer, okay? This should look pretty familiar to you, okay? You are finding a v2 when you know a v1 and they give you an acceleration. Are you kidding me? That's so easy. You're laundry listing, obviously, v1, v2, a, d, and t, okay? In this case, our initial velocity is 0 of both of these locomotives, okay? v2 is what we're trying to find. They tell us that the acceleration is 0.26 meters per second squared, okay? And it's a 6.4 kilometer track, so that's 6.4 kilometers, which is equal to 1,000 meters. 1,000 times 6.4 meters, which is 6,400 meters. All right. We have a v1, a v2, an a, and a d. Which equation do you use? By now, it should be like, obviously, we're going to use the v2 squared equals v1 squared plus 2ad. I put in my 0 squared for v1. Then I have 2 times 0.26. And then I'm multiplying that by 6,400 meters. Okay? I multiply that. I square it. Or I take the square root of what I get, and I get a value of, I'm realizing something. The whole length of the track is 6,400 meters, right? So that means that each guy has only gone 3,200 meters to get there. Now, I have a question. Scott, do I restart this video and make sure that I fix this from the beginning? And the answer is no, because this is what's going to happen in real problems that you guys do. You're going to catch something in the middle of it, and that's OK. And you just adjust from that point on, OK? So if you realize, oh, no, like this whole track is 6,400, which means that each of these guys is only accelerating for 3,200 meters before they collide, then you just go ahead and you make the switch to 3.2 and 3,200. And this is OK. Sometimes physics is messy, and you adjust. You adjust. OK? So you put that in there, and I get a value of my v2 for both of these before they hit each other as 40.7 meters per second. OK, here's what I know. I know that kinetic energy is this, right? And I know that if I just take this value and I put it into here, right, then I get a kinetic energy of, well, my mass is 1.2 times 10. Sorry, the weight is 1.6 times 10 to the 1.2 times 10 to the 6 newtons. So to get the mass, I just divide by 9.8, okay? And so I end up getting 1/2 times 1.22 times 10 to the 5 kilograms times 40.7 squared, right? And I get a kinetic energy of approximately 10 to the 8 joules, right? Just by multiplying that all together. But here's the thing. I want the kinetic energy of both of them. So I'm going to multiply that by 2, and I would get 2 times 10 to the 8 joules. Okay, so what have I done? Well, I know there's a situation where I have 2 locomotives that are set 6,400 meters apart, and they're racing towards each other at this acceleration. I find out what's going to be the velocity of one of them just before they hit each other, right? I use this equation to find that velocity, right? I know that my distance, it's going to travel 3,200 meters while accelerating at 0.26 meters per second squared. I find that velocity. I put that in my kinetic energy equation along with the mass of the train. Now, the mass was given in newtons, so I had to convert to kilograms, which I did. Put it all together in my calculator, press all the buttons. I get 10 to the 8 joules, and I want to know the kinetic energy of both of them, right? And I multiply by 2 to get that. And so one challenge that I leave you with, find out for me. So this is one of those little extra credit things that I'm going to hide in here, right? Let's say first 3 people to respond gets the points, okay? How many tons of TNT is 2 times 10 to the 8 joules equivalent to, okay? So how many tons of TNT is the same as these 2 guys just before they run into each other and collide? Good luck.